Have you ever wondered what reality truly is? Could there be more to it than what we can see, touch, and feel? Well, let's dive into the realm of dimensions to find out. Picture the world around you. It's not flat, is it? We live in a three-dimensional world where we can move forward and backward, left and right, and up and down. These physical dimensions form the framework of our reality, but what if I told you there's more to it? There's a fourth dimension that we're all familiar with, yet it's intangible. It's called time, and it's a dimension that constantly moves forward. We can remember the past, live in the present, and predict the future. In this regard, we are four-dimensional beings living in a world that's a blend of space and time. So we are four-dimensional beings then, aren't we? But could there be even more dimensions that we can't perceive? The idea of higher dimensions isn't just a figment of science fiction, it's a serious topic in modern physics. Let's dive into the fascinating realm of higher dimensions, guided by the lens of string theory. String theory, one of the leading candidates for unifying our understanding of the universe, posits a universe composed of more than the three spatial dimensions we're familiar with. In fact, it suggests that there may be up to 11 dimensions. Yes, you heard it right, 11. This is a bit of a leap from our everyday experience, isn't it? Now, you may be wondering if these dimensions exist, why don't we see them? Well, that's where the intriguing concept of compactified dimensions comes in. Imagine a tightrope walker high above the ground. To us, watching from a distance, the tightrope appears one-dimensional, a simple line. But let's say a tiny ant is crawling along the rope. To the ant, the rope has a second dimension. It can not only walk along the length of the rope, but it can also circumnavigate it, going around its circumference. This second dimension is compactified, curled up, and too small for us to perceive, but it's there. Similarly, string theory suggests that the extra dimensions it posits could be compactified, too small for us to perceive. In this way, they shape the fabric of our reality without us even realizing it. These compactified dimensions might be all around us, influencing the behavior of particles and the nature of the universe in ways we're only just beginning to understand. And this is where we hit a wall because our brains evolved to perceive a three-dimensional world, and imagining extra dimensions is a task that takes us to the limits of our imagination. So if these higher dimensions exist, why can't we perceive them? Well, the answer isn't simple, but we'll attempt to untangle this mystery in the next scene. Stay tuned as we delve deeper into our understanding of dimensions and how they shape our perception of reality. Our inability to perceive higher dimensions isn't due to a lack of imagination, but rather a result of how our brains evolved. We humans, like all creatures on Earth, are products of evolution. Our brains are designed for survival in our environment, and that environment is three-dimensional. This is why we perceive length, width, and height so naturally. Our brains also perceive time, a dimension in its own right. We can't see or touch time, but we experience its passage. We remember the past, we live in the present, and we anticipate the future. This ability to perceive time, to remember and anticipate, has been crucial to our survival and success as a species. But why only three spatial dimensions and one temporal dimension? Why not more? Well, the answer lies in the demands of our environment. Our ancestors didn't need to perceive higher dimensions to find food, avoid predators, or navigate their world. Three spatial dimensions and one temporal dimension were enough. To understand this better, let's consider a hypothetical two-dimensional world known as flatland. In flatland, beings can only perceive length and width. They have no concept of height. To them, a sphere passing through their world would appear as a circle that grows and then shrinks. They can't perceive the sphere in its entirety because they lack the ability to perceive the third dimension. Now, imagine a four-dimensional being looking at our three-dimensional world. They could see all of our insides and outsides at once, much like we can see all sides of a square on a piece of paper. But to us, this four-dimensional being would be incomprehensible. We might see parts of it appear and disappear as it moves through our three-dimensional space, but we could never perceive it in its entirety. So just because we can't perceive higher dimensions doesn't mean they don't exist. They're just beyond our grasp, beyond what our brains evolved to understand. And that in itself is a fascinating thought to ponder. The concept of higher dimensions isn't just an intellectual curiosity. It has profound implications for our understanding of the universe. Let's delve into that a bit further. For starters, higher dimensions could mean the existence of parallel universes. Imagine life as we know it, but slightly or drastically different, existing in a dimension we can't perceive. It's like flipping through a radio dial where each station corresponds to a different universe. We're tuned into our station, our universe, but there are countless others playing out different possibilities. This is a concept that is often explored in science fiction, but it could very well be a scientific reality. Another implication of higher dimensions is the nature of gravity. In our three-dimensional world, gravity pulls us down towards the center of the Earth. However, in higher dimensions, gravity could behave differently. It could be weaker or stronger or perhaps even non-existent. This could explain why gravity is so much weaker than the other fundamental forces in our universe, like electromagnetism. Perhaps gravity is leaking into other dimensions, thereby diluting its strength in our dimensions. Lastly, higher dimensions could be key to the unification of all the forces of nature. Physicists have long sought a theory of everything, a unified theory that could explain all natural phenomena. The existence of higher dimensions could provide the framework for such a theory. String theory, for instance, requires the existence of 10 dimensions to function. If proven, this could revolutionize our understanding of how the universe works. In essence, the concept of higher dimensions isn't just about adding more directions in which we can move. It's about rethinking our understanding of space, time, and reality. It's about challenging our perceptions and pushing the boundaries of our knowledge. So, the concept of higher dimensions may hold the key to some of the deepest mysteries of the universe. So, next time you look at the world around you, remember that there may be more to it than meets the eye. As we journeyed through the concept of dimensions, we explored how our universe is not as simple as it seems. We live in a four-dimensional world with 3 dimensions of space and 1 of time. But according to the intriguing string theory, our universe could have up to 11 dimensions. These potential dimensions, hidden from us, could hold the answers to some of the greatest mysteries of science. They challenge our understanding, push the boundaries of our perception, and compel us to reconsider what we thought we knew about the universe. The theory of dimensions is not just a fascinating concept, it's a testament to human curiosity, to our relentless pursuit of knowledge. And who knows, maybe one day we'll find a way to perceive these hidden dimensions. Until then, keep wondering, keep questioning, and keep exploring the mysteries of the universe.